Welcome back to the lecture series of electronics measurement and instrumentation. So in this lecture I am going to discuss about inkjet printers. So basically we already familiar about inkjet printer. Most of in the office places people are using inkjet printer. Similarly in our photo printing printer, most of the cases people are using this inkjet printer. So basically inkjet printer, roughly we are using a piezoelectric type or thermal type. There are two types of inkjet printer, and so the first we are going to discuss about thermal type inkjet printer. Then we discuss about piezoelectric type thermal inkjet printer. So basically thermal type printer or piezoelectric type printer, basically thermal type and piezoelectric type, these are basically pressure generation system. In the inkjet printer we generate a pressure so that the ink can move into the on the paper depending upon what input we have provided. So for the generation of this pressure we use either thermal type jet are we using piezoelectric type jet. See this particular diagram here we use a thermal inkjet. So here see there are a ink channel, ink is available in the ink channel. Then we create the pressure on this particular ink with the help of vapor bubbles. See this particular diagram, there are a thin film resistor, a silicon substrate, then we are using a plate, and between the two plate there are gap where ink droplet will coming out, and this particular the gap, just in the gap there are a vapor bubble that basically create a pressure so that the ink can come out of this particular jet, uh, thermal jet with pressure. So this thermal bubble technique, ink channel are formed on the surface of a planar substrate using a photo imageable polymer. So basically it is nothing but a photo imageable polymer. A small heater is formed using a thin film resistive metallic layer. See this again, this diagram, they are thin film resistor. So this basically thin film resistor is used to heat the particular ink. It's have the less than 1 micrometer thick in the wall of the ink channel leading to each nozzle. Nozzle is just the gap. This particular gap is called the nozzle, where this ink droplet will coming out. Typically such a heater is square in shape and 10 to 20 micron. So this basically this thin film resistor is nothing but a thin film work as a thin film heater, and its overall dimension is 10 to 20 micron. Low resistive thin film metallic conductor, this that is the thin film metallic conductor. Connection are attached in two opposite side of the heater resistor, and a pulse of electrical current is flow through the heater resistor for 1 microsecond. Actually this particular thin film resistor along with this thin film conductor, it overall generate a small heater. So what we can do, this particular thin film conductor that is connected to the resistor, and that resistor is create the heating with the help of the pulse of electrical current, and the duration of the pulse is 1 microsecond. It means very small duration. Similarly the shape of this particular heater is 10 to 20 micrometer. So, and the amplitude of the current is designed to heat the resistor enough to boil the ink. It means the current flowing in the resistor conductor, it means there is a combination or a heater in such a high that it is able to boil the ink in the ink channel. A thin layer of ink that is about 0.01 micrometer to the resistor explosively boils, forming a vapor bubble and expanding about 1000 times in the volume. See this particular, it means a very small quantity. The volume is a basically a small quantity. See, the layer is given by 0.01 micrometer, but it boils and it's form a vapor bubbles. That is basically a vapor bubbles, and expanding about 1000 times in the volume. After forming the bubble, this particular bubble is expanded. This volume expansion create a pressure pulse in the fluid, causing the ink in the nozzle to eject towards the paper. That is the overall the working. Again, I repeat, summarize the whole concept. In this concept, the ink is placed in a tank that is called the ink channel. Then there are a thin film conductor, a thin film resistor. This basically the combination of the thin film conductor and thin film resistor form a heater. So when we provide a current to the resistor with very small duration, then this particular thin film conductor, it's boil the ink. The thickness of the ink layer is 0.01, but it is boiled in such a that it's form a vapor bubbles, and that particular vapor bubble expand in the volume. So due to the expansion of this vapor bubble in a volume creates the pressure, and so that the ink available in the channel is coming out from the nozzle in a form of ink droplet. That is the basically the working of a thermal type pressure generation method or thermal type inkjet printer. So basically in the inkjet printer we are using two types of the nozzle. One is use the thermal type, another one is use the piezoelectric type. So then the next slide we are going to discuss about a piezoelectric type. Right. So after several microsecond, vapor and bubble cool and collapse. Then the surface tension of the ink diminishes in the nozzle. That I already explained. So in the second pressure generation method, that is the piezoelectric. It consists of a piezoelectric material, so or we also call the piezoelectric transducer. So see this particular, I am already mentioned that there are a piezoelectric transducer. This yellow mark is represented the ink, and it's flow in a particular manner. See here, this flow in this particular manner, so it form a ink channel. Then there are some metallic plates. So here piezoelectric material have deforming property. We already know that this, once we have applied the high electric field, then there are piezoelectric material is deformed, and then we remove the field, then it's again regained to its actual shape. So basically two configurations are commonly used. First is we use the piezoelectric rod with elongate under applied field, or we use bimobs which bend. So either we use the piezoelectric rod or we use bimobs. In either case, the material is configured so that they deform one of the wall of the ink channel leading to each nozzle. These deformation seques the channel, create a pressure pulse and eject the ink from the nozzle. Actually, once once we have applied the field in a piezoelectric transducer or piezoelectric material, it's create the deformation. This deformation create the pressure in the ink channel. Due to that pressure in the ink channel, a ink droplet is come out of the nozzle. Then again we explain how this whole mechanism will work. So basically an elastic diaphragm typically isolate the crystalline piezoelectric material from the ink. See here, this particular ink is flowing in a particular channel and there are a piezoelectric material. So we separate this both. Electrical pulse which energize these piezoelectric elements are once again in microseconds. It means in an interval of a microsecond they energize. The ink channel in a piezoelectric inkjet printhead can be formed using a variety of the technique, but one common method is lamination of stack of metal plates, each of which include precision micro-fabricated features of various shape. So actually To separate this piezoelectric material to the ink channel. Here what they are explaining that they using a lamination of a stack of metal plates, that were laminated metal plates. Actually it create the pressure in the inkjet channel, and similarly it separate this inkjet and piezoelectric. It means it isolate the both inkjet channel and a piezoelectric crystal. The ink delivery quantity can be adjusted by a drive control. Drop size control is easy and high print quality based on the grayscale representation. Printer does not deteriorate and can be used almost indefinitely because heat is not generated. Reliability is very high, suitable for increased speed. So here they just compare both the system. So in the piezoelectric generation method, pressure generation method, it is better than the thermal generation method because heat is not generated. Second, this particular deformation we have created, it's regain to the actual shape after some particular time. It means we can printer is not deteriorated because whatever deformation we have created, it can easily remove, and again we can create deformation. But in the previous case we are creating the heat, so the heat, due to the creation of the heat in the system it will deteriorate with time. So the reliability and print quality, if you consider reliability and print quality, then our piezoelectric pressure generation method is more reliable and provide high quality print output in comparison to our thermal generation pressure generation method. So and speed of the printing of this particular technique is also high. Then if you combine both the system, then we see that is the block diagram of a inkjet printer working. Here see that here there are ink bottles where ink is flowing through the ink supply pump. Then it can move to the ceramic crystal where we can it have the nozzle, and we generate a pressure either by using this particular method, thermal generation method or piezoelectric. That droplet is moving and it can be deflected with the help of the deflecting plate, and it is printed whatever matter we want to print, and then remaining ink is also collected by this glutter. See this particular diagram, it again clear, this collected ink is again moved to the ink tank. So to print a character, a paper, individual drop of ink or electronically controlled. See this particular diagram, it is very clear. Ink is pressure by the ink supply pump. See this particular ink supply pump, it's create the pressure and flow from the ink bottle to the nozzle. So this ink is flowing to this particular nozzle. This particular nozzle use pressure generation system or thermal generation system. Any system can be used to create the pressure. Then the drop of ejected from the nozzle at high speeds, they pass through charge electrode tunnel and then on between the deflection electrode. So this particular is called charge tunnel and deflecting electrode. Here the drop was deflected by an amount which depends on the charge they were given by the charge electrode. After the drop leave the region of deflection electrode, they continue to travel in their new direction until they pass out of the print head and to the substrate. Drop that are not required for printing is caught by the glutter and subsequently recycled back to the ink bottle. No, not gutter, and subsequently recycle back to the ink bottle. So see this particular diagram, I think the working is clear. So first we create a high pressure inkjet inks drops, and then this drop is moved to a electronic system that create the amount of the deflection, and then it's moved to the substrate for the printing. Some of the ink that not used for the printing is collected by the gutter, and and then it is moved to the ink tank. So that is all about the working of the inkjet printer. That's all about the today lecture. In the next lecture we have discussed about the DC emitter. Thank you for your attention.